Okay, please, can you hear me? Can you hear me now? Hello, can you hear me now? Can you hear me? Yeah, let me know if you can hear me. Okay, guys, you're welcome to class again. All right, so I'm trying to fix one or two things. Okay, so today we are going to continue from where we stopped the last time. Don't forget, the last time um, we introduced to us solid shapes. Okay, so we look at common solid shapes. So we look at cube, cuboid, and so on. All right, and what we were able to do the last time was to derive the formulas. All right, so if you missed the last class, make sure you get it and make sure you watch the last class, because how we derive all those formula was explained in details. All right, so you don't need to cram formulas because you have a lot of formulas to deal with. So once you get the formula, you don't have any problem. You understand how the formula is derived. The reason why many students have problem with this is because of they need to cram a lot of formulas. They don't really understand the idea of the formula. So once you don't get that, you'll be having issue because you have crammed the formula. So make sure that you watch the video, the last video um, I did yesterday. All right, so it's going to be helpful. All right, so now we are going to continue from where we stopped the last time. Don't forget, as you are joining the class, greet the whole class, say hi, okay, and don't forget to tap the like button. If you are new on this channel, you have not subscribed, ensure you subscribe to this channel. All right, okay, so I want to believe you have your biro, your notes, and your calculator or four-figure table close to you. Make sure you have that, because you are going to be doing one or two things for me today. All right, so now let's start with the first question here. So I'm going to do this one. Now let's look at it. Now a rectangular tank is 70 centimeter long, 30 centimeter wide, and 20 centimeter high. So you have to find out the number of liters of water that it can hold. All right, so a rectangular tank will look like this. Okay, just like a cuboid. All right, so all right, so this is what it's going to look like. All right, so we want to know the volume of water that this tank is going to contain. That's what the question is asking for. Now look at it. We have been given that the length is 70 centimeter and the wideness is 30 centimeter, while the depth, which is the height, now is 20 centimeter. So the question asks you to find the volume in liters. Now let's get the volume in centimeter cube. So that's the first thing we're going to do. Now don't forget the formula for finding volume of a cuboid. This is a cuboid. Okay, so the formula is V equals to LBH. All right, the length, the breadth, and the height. So now let's plug in the values. So we have the volume equals to 70 times 30 times 20. All right, so let's multiply everything. 7 times 3, that's 21. 21 times 2, that is 42. So that's 42,000 centimeter cube. All right, you get that now? So this is the volume of water that this tank is going to contain. Now, but what is the question talking about? The question wants you to get the capacity of this tank in liters, not in centimeter cube. So we need to convert our answer to liters. All right, so I must know the relationship between liters and centimeter cube. So now, how many centimeter cube make 1 liter? All right, so if you know, I want you to drop that in the comment section. How many centimeter cube make 1 liter make 1 liter? How many centimeter cube make 1 liter? Okay, can you drop that in the comment section if you know? All right, so if I didn't see any answer, so we'll just continue. I will tell you what it is. Yes. Is there anybody giving us the answer? How many centimeter cube make 1 liter? Okay, nobody is giving us the answer, so that means I have to do that. Okay. All right, so now 1,000 centimeter cube will give us 1 liter. Okay, to give us 1 liter. That is it. All right, so now 1 liter will be what? So I be 1 centimeter cube. 1 centimeter cube now is going to be 1 over, right? You just divide both sides by 1,000. So 1 over 1,000 liters. Okay, so now we want to know what is 42,000 centimeter cube in liters. So that means 42,000 centimeter cube is equivalent to 42,000 over 1,000. So that's going to be liters. All right, so this one cancels this. So we have 42 liters. So this is the volume of water that this tank can contain. So that's the answer. Yes. Any question based on what we have just done now? Any observation? So raise an observation based on what we have done. So if there's no observation, we'll move down to the next thing. So please ensure that you say hi. Say hi as you're watching. Make sure you say hi, you greet the class. And don't forget to tap the like button. Make sure you do that. Okay, now let's move down to the next question. Now I have another question here. Right, let me see. Is there any observation? Any question based on what we have done? Or no? All right, so no question. Let's move down to the next thing. So there's no question. Find the volume. Find the volume of the solid blue. Okay, now can we look at this problem on the board? So how do we solve this? The question asks us to find the volume of the solid below. So this is the solid. Now, look at it. When I was explaining how we derive the formula for prism, I told you the cross-sectional area times the height. That gives us the volume of a prism. Example of a prism is your cylinder. The cross-sectional area of the top of a cylinder is a circle. So we say pi r squared times h. That gives us the volume of a cylinder. The same thing also applies to your cuboid that we just did now. The cross-sectional area, which is a rectangle, times the depth. Alright, so now this is another one here. It's also a prism. So the cross-sectional area here times the depth. Now the depth in this case now is going to be 20 centimeters. So I need to get this cross-sectional area. So now let me bring out the diagram. That will help me. Now the front of this prism, let me bring it out. Now it's like this. So this is 6 centimeter. This is 5 centimeter. And you know, this length here is the same thing as this. So this is going to be 2 centimeter. All right. Okay. So now we want to get this is right hand here. So we want to get the area of this thing. Now when you look at this plane shape, now this is a trapezium, because this side will be parallel to this. Okay, it's going to be parallel to this. So this side is parallel to this. So now to get area of a trapezium, you know the formula. We've done that in plane shape. So A equals to 1/2 A plus B times H. Why A and B are the two parallel sides, and the H is the distance between the two parallel sides. Okay. All right. So now here in this diagram now, A is 2, B is 5, and H is 6 centimeter. All right. So let's plug that into this formula. So we get the cross-sectional area of this solid. So we have area equals to 1/2, 2 plus 5 times 6. Right? So now this gives you 1/2 times, this is 7 times 6. You get that now? So 2 goes there 1, 2 goes there 3. So we have 3 times 7, that's 21 centimeter square. So this is the area here. All right. So now the next thing now is to use the area here, the cross-sectional area, to calculate. You multiply that with the depth. Okay, so that gives you what? So we have volume. Volume is the cross-sectional area times the height, and that is 21 times the height. What is the height? 20. So we have 20. So, and that gives you what? 420 centimeter cube. All right. So this is going to be the volume of this solid. So suppose the question asks you for the volume in liters. So just divide this by 1000. That's going to give you 0.42. Okay. So that is going to be in liters. So if I'm correcting it to liters now, so it's going to be 0.42 liter. So that's it. All right. So I hope you all get that. So any question before I move down to the next thing? All right. Okay, who is asking Sophia? Okay. What level? Once you're in senior secondary school, the question is meant for you. Right? Everything we are doing here is for senior secondary school. So once you understand what we are doing in senior secondary school, so you should not have any problem. All right? So that's it. Okay, so now let's move down to the next question. So you are in SS1, you are in SS2, you are in SS3, so this class is meant for you. All right. Okay, the next example, we have if the volume of a rectangular Okay, all right. Great student. Let's see how do we solve this problem. Now, if the volume of a rectangular base pyramid is 70 centimeters square and its base area is 28 centimeters square, okay, you have to calculate the height of the pyramid. All right, can I give you just like a minute to attend to this question? So you have the formula with you. Can you try that? Let me just give you a minute. Let me see what you are going to do. So if you have the answer, you can drop that in the comment section. Okay, so you have to be fast about it because I want to solve this question very fast. So this question is under pyramid. It's under pyramid. So this question is under pyramid. All right. Miss Sophia or Mrs. Sophia. All right, I can see what you dropped there. Your child is in basic 6. All right, this a little bit advanced to that class. All right, because what we are doing now, at least the student should be in basic 9 upward. Basic 9 upward. All right. Okay, so that's it. All right. So yes, anybody with an answer to that before? Okay, nobody's dropping an answer. I have to move very fast. Let's solve it together. So we move down to the next thing. Now, if the volume of a rectangular base pyramid is 70 centimeter square, so we have been given the volume of pyramid to be 70 centimeter cube, and its base area is 28 centimeter square. So base area, so we have been given the base area to be 28 centimeter square. Now the question is to calculate the height of the pyramid. It's very easy. So all I need to know is the formula for calculating volume of a pyramid. So once I know the formula, so I'll just plug in the values and I get the height. Now let's look at it. So volume of finding formula for finding volume of pyramid is 1/3 base area times height. So this is the formula. Okay, so now the volume has been given to be 70 in the equation. 1/3 times the area, that's 28. That has been given in the question. So times the height. Okay, so now let's try and simplify. So this is 70 equals to 28/3h. So here you can divide both sides by the coefficient of h. So that is going to give you what? 70 times 3/28 equals to h. You get that? So once you divide both sides by a fraction, once it comes to this other side, so the denominator turns to numerator, while numerator to denominator. So now can we break this one down? Now 2 goes here is 35, and the 2 goes here is 14, right? Okay, so 7 goes here is 2. 7 goes here is 5. Alright, so that means h now is going to give us 5 times 3, that's 15/2. Okay, so h is going to be 7 number 1/2 centimeter, or you write h to be 7.5 centimeters. So this is the answer to this problem. All right, so I hope you understand that. Okay, so any question based on what we have done? I'm moving down to the next question. Any question, any observation? All right. Okay, so let's move down to the next thing. Next example, we have the density of copper used for a spherical is 8.9 kilogram per meter cube, and the radius of the ball is 3.5 centimeter. Calculate the curved surface area, B, volume, and C, mass of the sphere. We have 5 equals to 22/7. Okay, so now can we all see the question? So you can read in between lines and see. Does it look like what you can solve? All right, so now let's do this one together. Let's do this together. All right, now the density of a copper used for a spherical ball is 8.9 kilogram per meter cube. And the radius of the ball is 3.5 centimeter. Now calculate the curved surface area, 2, the volume, 3, the mass of the sphere. Okay, so now can you see the 3 things we are asked to do? All right, so now let's start with the first one. We have to calculate the curved surface area. Now, curved surface area of what? Of a spherical ball. So I need to know the formula for calculating curved surface area of a sphere. All right, so now make sure you go through my last video, the one I did yesterday. So I explained all those formulas are there. So you must have the formula at your disposal and you understand how those formulas are being derived. Okay, curved surface area. Curved surface area of a sphere is 4 pi r squared, right? 4 pi r squared. That is the curved surface area. Now, so you just plug in the values. We have 4 times 22/7 times, now the radius is 3.5. So we have 3.5 times 3.5. You get that now? So 3.5 goes here 1, 3.5 goes here is 2, 2 goes here 1, 2 goes here is 11. So we have 4 times 11 times 3.5. Okay, so and that is the same thing as 44 times 3.5. Okay, so let's multiply these two. What do you have when you multiply the two? Let's see, we have 44 times 3.5. So 5 times, that's 5 times 4 is 20. 5 times 4, 20. So that's 24. Okay. Now 3 times 4, that's 12. 3 times 4, 12. So we have this 0, 6, 5, 1. So the answer is going to be 156. 156. And what's going to be the unit? It's going to be in centimeter square. So that is it. Do you understand that? Now, so we have gotten the curved surface area of this spherical ball. Now, the next question is you have to find the volume. What is the volume of this sphere? So now we have formula for finding volume of a sphere is 4 over 3 pi r cubed. You get that now? So now let's plug in the value. So we have 4 over 3 times 22 over 7 times, what is the radius? 3.5 times 3.5 times 3.5. You get that now? So 3.5 goes in 7, that's 2. 3.5 goes there, that's 1. So 2 goes there, 1. 2 goes there, 11. So what we have here now is 4 times 11 times 3.5 times 3.5, everything all over 3. Can you evaluate that? Now try that and drop the answer in the comment section. So when you multiply and you divide by 3, so that's 44 times 3.5 square. Alright, so and divide that by 3. So what do you have? So here, what I have here now, is anybody with the answer? Let me see, is anybody giving me the answer? So what's the answer to that? Okay, you are still working on it. Alright, so what I have here now is 179.67 centimeter cube. Alright, so that is the volume. So we now have the volume for this. So now let's put this one down. Volume is 179.67 centimeter cube. Now let's move down to the last part of the question. Now the question asks us to find the mass of the sphere. We want to get the mass of the sphere. So how do we get mass of the sphere? Now when you look at the question, they have been given one parameter here. That is the density. So I need to know the formula for density. Density is mass over volume. Mass over volume. That is the formula for density. So density equals to mass over volume. So you can write this formula down in your jotter. So you take note of it. So the formula for finding density of a material, so it's mass of the material over the volume. So that gives you density. So but in this case now, we are not looking for density. We want to get the mass of that spherical ball. So we have mass will be equals to density times volume. So that's what you're going to have now. You get that? Okay, so now, but there will be an issue. Now, what is the issue? Now, when you look at the unit of the density given now, is in kilogram per meter cube. But look at the volume we have, is in centimeter cube. So there will be an issue. So what I need to do here now is I will convert this volume in centimeter cube to meter cube. So there will be consistency in units. Alright? So now let us convert this. So now I now begin to ask myself, how many centimeter cube makes meter cube? Make 1 meter cube. So now let's see. 10 raised to the power of 6 centimeter cube. Same thing as 1 million will give us 1 meter cube. So make sure you master this. So you are supposed to be familiar with this. 1 million centimeter cube make 1 meter cube. Alright, so now in this case now we want to convert this volume to meter cube. So that means we are going to divide this by 10 raised to the power of 6. Alright, we are dividing by 1 million. So that means volume in meter cube is 179.67 over 10 raised to the power of 6. Okay, so this is going to be in meter cube now. So this is meter cube. Okay, so having this now, we can now find the mass. Alright, so we now say mass is the density, that's 8.9 times the volume, 179.67 over 10 raised to the power of 6, right? Okay, so now what do we have? If we do that, we have 8.9 times. Now let's divide this by 1. So just move the point 6 times. So that's going to be 0.0017967. Okay? Okay, so 1, 2, 3, 4, 5. Okay, I think we need one more 0. Okay, all right. 1, 2, 3, 4, 5, 6. All right. So when you divide by 1 million, so this is what you are going to have. So just use this to multiply this, and let's see what you are going to have. Okay. So 8.9 times please try and compute that over there. So let's see what you have as your answer. Okay, so I've gotten my own answer. So mass, is there anybody with the answer? The mass. So what do you have when you multiply? Okay, thank you, Divine. So do you have the answer? Okay, so make sure you are computing something. You are doing something, make sure you are participating. All right, so we have 1.5999 centimeter. Okay, sorry, that's going to be in kilogram. So that's what we have. So now let's correct this to 3SF. 1, 2, 3. So that is so approximately 1.60 kilogram. So 3SF. So this is going to be the mass of the spherical ball. Yes, so that is that. Any question based on that? If you have any question, you can drop that in the comment section. Let me see before I move down to the next question. Any question? Is it well understood? Yes. Right, well done. Okay, thank you, Raji. Thank you, you're welcome. Yes, what we just solved now, is it well understood? Toyosi, is it well understood? All right, thank you, Divine. Okay, so Divine said we should go on. That means it's well understood. All right, so I want to believe it applies to others as well. Okay, now can we look at another question? Let's look at another question. Okay, this is a sphere. The sphere has a volume of 200 centimeter cube. What is the volume of a second? Circumference sphere. Radius. Okay, this is another interesting question. Yes, can you see this question? Please, I want you to read in between lines and tell me the answer to that problem. Yes, if you can find the solution to that problem, drop it in the comment section. If you get the answer, I clap for you here. All right, let me just give you a minute now to attend to the question. All right, so now reading between lines. So a sphere has a volume of 200 centimeter cube. What is the volume of a second sphere whose radius is a quarter of the radius of the first ball? All right. Okay, so that's it. Can I give you a minute to try this? Okay, so let's solve the problem together because of time. So let's do that together because of time. So you can compare with what you are doing. So by the time we start solving. Now, look at the problem. Now, a sphere has a volume of 200 centimeter cube. What is the volume of a second sphere whose radius is a quarter of the radius of the first ball? Now, the first thing I need to do now is let me get the radius of the first sphere. So, two things are being considered here now. They are talking about two spheres. One is big and one is small. Now, and the bigger one have a radius r. Now, the question now is saying that the second one, which is small, the radius is quarter of this. That is to say, if this one is 4, this one is going to be 1, the radius is going to be 1. So if this one is 8, the radius here is going to be 2. So that's what the question is saying. So whatever you have as radius here, divided by 4, is going to be the radius of the second one. That is it. So you now have the idea of the question now. So now let us find the radius of the first one. So once you get the radius of the first one, so we just divide it by 4 and put it inside the second sphere, because the second sphere have a radius of 1/4 of that of the first one. So now we know the formula for finding volume of a sphere is 4/3 pi r cube. Alright, so this is the formula. So here now we have been given the volume to be 200. Let's plug in 200. We want to get this r. So we have 4 pi r cube over 3. So you can write it this way. Alright, so now let's cross multiply. If you cross multiply, we will have 600 equals to 4 pi r cube. So let's divide both sides by 4 pi. So we now have 600 over 4 pi. 4 pi. And that is r cube. Don't forget, what we want to get now is r. Okay, so now 4 goes here, 1. 4 goes here is 150. So this is 150. So 150 over pi equals to r cube. So I cannot get the answer for the radius of the first sphere. So just take cube root of both sides. So I have cube root of 150 over pi equals to r. So that's what you have. You get that? So now, the second sphere, I want to get the question asks me to find the volume. The question says, what is the volume of a second sphere whose radius, the radius of the second sphere, is a quarter of the radius of the first sphere? Do you understand that? So now let's get the volume now. Before we get the volume, let us get the radius. Now let's call that radius, let's say radius r2 to be equals to radius of the second sphere. Okay. So we can now go ahead now and get the volume. Can get the volume of the second sphere. But then, have we gotten the R? So we have R2 is what? 1/4 of this cube root of 150/pi. You know, this is the radius of the first one. So the radius of the second one is 1/4 of, okay, 1/4 of the radius of the first one. So this is the radius of the second sphere. So, all right, so I'll now write the volume of second sphere will be equals to, you know, that's 4/3 pi r cube. You get that? So we have 4/3 times pi times the volume. Look at the volume. This one should be R2. You get it now? So R2 is 1/4 cube root of 150/pi. So everything raised to the power of 3. Do you understand now? So we have just replaced R2 with what we have here. Can you see that now? So we plug in the value of R2. So that's what we have here. So now we have 4/3 times pi times, now we multiply each of them by themselves 3 times. So this 1/4, I'll multiply it by itself 3 times. So 1/4 times 1/4 times 1/4. So that's going to give me 1/64. Because 4 times 4 is 16. 16 times 4 is 64. Okay, so that gives me 1/64 times. Now I will multiply this by itself 3 times. So it's as good as just saying this one will cancel this. Alright? Because this one is more like raised to the power of 1/3. So when you multiply that with this, it will cancel out. Okay, so now you have 150/pi. Alright, so now can we simplify? You can see this one will cancel this here. So 3 goes there 1, 3 goes there is 50. Right? So 4 goes here 1, 4 goes here is 16. Alright? So then we now have we can still simplify further. 2 goes here is 8, 2 goes here is 25. So you have 25/8. That's going to be the volume. So you can simplify further. So that is stereo number 1/8 centimeter cube. So this is going to be the volume of the second sphere. Or you write it like this. I want to write it in decimal. That's 3.125 centimeter cube. So this is going to be the answer to the problem. Alright, so any question based on what we have just done? The volume of the second sphere. Any question based on what we have done? Okay, so if there's no question based on what we have done, alright, so we are going to be hanging it here today. So we are going to be rounding up the class here today. So tomorrow is another day, so we are going to go further into questions on mensuration, and tomorrow we are going to be looking at some technical questions. Okay, so make sure that you are around for the class. All right, so if you have not subscribed, make sure you do that, because you will not be notified if you didn't subscribe. So make sure you subscribe. All right, and make sure you inform your friends. Let them know about the class. Let them come in. Okay. So thank you very much. Those of you that started with me from the beginning down to this period where we stopped. So I thank you very much. For those of you that are just joining the class for the first time, you are especially welcome. All right. Okay. So I'm happy, I'm excited, I'm glad seeing you. Thank you very much. Bye-bye. Okay, thank you, Divine. Yeah, thank you. God bless you too. God bless you. Thank you for appreciating me. All right. Darasimi, thank you. Thank you. Thank you for appreciating me. You're welcome. All right. Okay, Ajayi Amidat. It's been a while. I've seen this person. Okay, thank you very much. Thank you for thanking me. All right, I appreciate you. All right. Oh, thank you, Darasimi, for appreciating me. Thank you. Um, you're welcome. Ajayi Amida, you're welcome. Thank you for appreciating me. Also, Mutiat Adebayo, thank you. God bless you. Thank you. God bless you. All right, Divine, I really appreciate you. Okay, you're actually participating in the class. I notice you. Thank you. So, all right, I thank everyone. Thank you, everyone. Yeah. Okay. Okay. So those of you that didn't join the class in time, make sure you go through the class from the beginning. You can go through the class and let's see. So Toyosi, thank you. Thank you. You're welcome. God bless you.